Physically, what's going on in this problem is that there is going to be a reaction that occurs. It's exothermic, which means it releases heat, and this heat goes into a water sample, and the water sample warms up. There's going to be an increase in temperature. So the question is, what is the delta T? And the delta T is going to be determined by the amount of heat that's released by the reaction occurring and the mass of water that we have. So to determine the delta T, we need to know the amount of heat that's involved. And we're going to use this thermochemical equation as a type of conversion factor. We start with our measured number of methane. So we have this much methane. We want to know how much heat is released when this much methane is reacted. So here's our equation for the amount of heat that's going to be released. We have so many moles of methane, and get this from our problem statement, and from the equation we have generated a conversion factor, and the conversion factor is set up such that the moles of CH4 cancel out. Now in this case, the coefficient associated with methane is 1. As we saw in other problems, this coefficient is different, so we do want to be careful to make sure we take note of what the coefficient is. So every mole of methane that is combusted releases this amount of heat. Now we need to convert to joules because the specific heat capacity of water is given in terms of joules. All right, so we've calculated the heat that is released by the combustion of 0.8 moles of methane. And this is the heat that's going to be used to warm up the water. So the next step is to calculate this delta T, and from delta T we can get our final temperature. So here we are. We've determined the amount of heat that was released in the reaction. We want to determine the delta T so that we can add it to Ti to get Tf. So we have our delta T. We're going to add that to our initial temperature of 16 degrees C. And now when we look at sig figs, we see that we can justify just 2 sig figs going back to the initial moles of methane. And we have our final answer of 66 degrees C.